This video is going to take a look at how to solve a system of linear equations using the substitution method. And the substitution method is really useful in a sense that it's going to give you exact answers rather than estimations like the graphing method. But it's also better to use, or most useful to use, when one of the equations is already solved for one of the variables. One is already maybe set up so it says y equals or x equals. Or if one of the variables has a coefficient of 1, which makes it easier to solve for that variable. Otherwise, you may get a lot of fractions, and I know how you guys feel about fractions. You can you can pause the video and read through the substitution steps, but I think I want to jump to the example so you can actually see the process in action. Okay, so I'm going to skip 2 slides and you can pause and read those. All right, so here's our first example. We have x plus 3y equals 5 and 2x plus 3y equals 4. And we want to use the idea of substitution. And so what I noticed right away is that in this first equation, the x has a coefficient of 1, which means it's going to be easy to solve for that particular variable. So I'm going to go up off here to the side, and I'm going to solve x plus 3y equals 5 for x. It doesn't matter whether you solve for x or y in the substitution method. So I'm going to subtract 3y from either side so that we have x equals 5 minus 3y. Then we take that answer that we just found and we substitute it, hence the name substitution. We're going to take this equation and we're going to substitute it into the second equation in place of x, because we're saying that x equals 5 minus 3y. So if we do that, we would have 2 times, and in place of x, we're going to put 5 minus 3y. It's a direct substitution. And then we continue, we still have plus 3y equals 4. And so then I need to solve that expression for, or that equation for y. So I would distribute 2 times 5 is 10. 2 times minus 3 is minus 6y. Plus 3y equals 4. Combine like terms, you're doing good old basic algebra. So I have 10 minus 3y equals 4. I'm trying to solve, in this case, for y, because now that's the only variable that remains. I've gotten rid of one, so I have minus 10, minus 10. So I have negative 3y equals negative 6. Then I'm going to divide both sides by negative 3. So I find that y is positive 2. So then I take the value of positive 2 and I go back to the original equation, one of them. It really doesn't matter which one. And I substitute back in, okay, to find the corresponding x. And you may say, well, why can't I go up here to where x is already solved? You can, but if you solved it incorrectly, you might get it wrong. So we have x plus 3 times 2 equals 5. So that's x plus 6 equals 5. Subtract 6 from either side. We get x is negative 1. So the ordered pair that would be the solution to this system is negative 1. We always put the x first. 2. And again, then you can mentally check or go off to the side and check. We would have negative 1 plus 3 times 2, and that's supposed to be 5. So that's negative 1 plus 6. 5 does equal 5. It works. 2 times negative 1 plus 3 times 2, and we hope that that's 4. So we have negative 2 plus 6. So 4 does equal 4. It also works in the second one. So I am I know without a doubt that the solution is -1, 2. Now, again, it's a lengthy process, okay? But just walk it through. All right, here's another one. -x plus 2y equals -1. 5x minus 10y equals 6. Okay, again, I noticed that in the first equation, x has a coefficient of -1 in this case, but that still makes it reasonably easy to solve. So I'm going to solve -x plus 2y equals -1 for x. So I'm going to subtract 2y from either side to isolate the x. So I have -x equals -1 minus 2y. Then I have to divide through by -1. That gives me x equals 1 plus 2y. Negative and a negative make a positive. Negative and negative make a positive. Then we take that equation, that expression, that equation, x equals 1 plus 2y, and we substitute it into the second equation in place of x. So I would have 5 times 1 plus 2y, taking out the x and substituting in 1 plus 2y, because we know they're equal, minus 10y equals 6. And then we do the algebra. Okay, so I'm going to distribute to eliminate the parentheses. 5 times 1 is 5. 5 times 2y is 10y. Minus 10y equals 6. And then I combine like terms. So if I combine like terms, I have 5 plus 10 minus 10 zeros out, and I end up with the expression, there's no variable that remains, and it says 5 equals 6, which is a false statement. Because that is a false statement, that lets me know that this particular system has no solution. So if you work through the problem and you end up with no variable and a false statement, you have no solution. Right, one more. -3x plus y equals 2, and 12x minus 4y equals -8. In this problem, I noticed that the first equation has a 1 coefficient on the y. So I'm going to go off to the side and I'm going to solve for y. So I have -3x plus y equals 2. We add 3y to either side to isolate the y. So we have y equals 2 plus 3x. Okay, once you have it solved for y, we take that equation and we substitute it into the other one in place of y. So in this case, I would have 12x minus 4 times, and in place of y, we put 2 plus 3x, and that's going to equal -8. And again, we do the algebra. Okay, so we're going to distribute. We have 12x minus 4 times 2 is -8. Minus 4 times 3x is minus 12x, and that equals -8. Combining like terms, we have 12x minus 12x, which again zeroes out, and I have -8 equal to -8. In this case, I have no variable remaining in my problem, but it's a true statement. So that means as long as I plug in an ordered pair that satisfies the equation -3x plus y equals 2, we're going to have a solution. So this one has an infinite number of solutions. Okay, so that's the substitution method.